Assalamualaikum and good day to everyone. So today we'll be discussing our continuation to introduction to material science and engineering. So as I've covered before, the content will be regarding this introduction, material science and engineering, and classification of materials. Okay, so the lesson outcome, again, this is the lesson outcome. You can read it by yourself. So there are 3 lesson outcomes. And I would like to reiterate again material science and engineering, what it is. So material science and engineering is a study of basic knowledge in terms of structure, properties, and processing of materials, what I call as theory. And materials engineering is the use of fundamental and applied knowledge of materials to cover into products that meets the requirement of society. So I call this applied. So when we combine both of these, materials science and engineering, it becomes a resultant knowledge of the structural properties, processing, and performance of engineering materials. Therefore, it is very, very important for you to remember this tetrahedron of material science and engineering, where we have the structure, properties, performance, and processing, which are interacting with each other. And when we understand that it is interacting with each other, then we could understand better material science and engineering. Okay, moving on. As I mentioned before, engineering materials consists of several materials, and we're talking about overall materials available around the world. So one of which is metallic, polymeric materials, ceramic materials, composite, and semiconductor. In this course, we will be focusing more on the upper side of the materials list, particularly for metallic materials. But in all of these materials have mechanical and physical properties we have to consider. So what we mentioned before, when we say properties of materials, we are referring to the way the material responds to the environmental and external forces. So there are several properties of materials that you have to consider: mechanical properties, physical properties, electrical and magnetic properties, thermal properties, optical and chemical properties. So we will go through some of these one by one, but we won't go into much detail of some of the others, like optical properties, because this is a little bit more advanced. Now, once we know that there are several materials around the world, and that all the materials have its own properties, then we understand that because of these specific properties, they are used in specific parts or specific functions. So one example here is engineering materials application in a car. Okay, so we have a car, and right, I think even though you don't take this course, you know already that the cars consist of several materials and they are not the same. Some have hard, that the hardness is high, very good strength. Some have a very elastic property, and some have shining properties, some have transparent properties, and things like this. So in a car, in general, we can say that since steel is the most widely used metal in the world, we can see that ferrous, or what we call as steel, are consisting of around 50 to 60% of the whole car. So the main material used in a car currently is iron or steel, which is ferrous material, and that is around 50 to 60%. What others are inside the car? So for instance, we have aluminum, which is around 5 to 10%. We have plastics as well. Okay, so maybe some of the components of the car, like inside the interior of the car, are made of plastic, so this is around 10 to 20%. And we also have others, right? So this is including the tires, right? We're using rubber and whatnot. So all in all, when we combine all of this, it consists of around 1.4 ton, 1,473 kilograms of weight, that is of a typical car. Nowadays, we have more and more other materials being put inside the car rather than just relying on steel, so that we can make the car more lighter. So steel is very strong, but at the same time it is heavy as well. So if you can get something which is high in strength but the weight is less, then it is better. So we are moving towards materials that are light but at the same time still quite strong, for instance like aluminium or magnesium and things like that. Okay, moving on. Now we're going on to explain in general some of the materials that we've discussed, listed just now. So for instance, the metallic materials, the ceramic materials and things like this, and we go a little bit more detail. So what we call as metallic materials by definition is a materials that is composed of one or two metallic elements and may also contain a non-metallic element as well. So what we say as metallic elements here is the chemical elements in the periodic table that we consider as metals. Okay, and some of it can also contain non-metal elements as well. So some of the properties that is important in metallic materials are it's crystalline in structure. So we'll go into more detail what crystalline means. So basically the atoms are aligned properly in the microstructure. We also have thermal and electrical conductors. So thermal in a sense, the heat conductivity is good and the electrical conductivity is good. So we can conduct electricity through our material, and we can also conduct thermal heat through this material. We also have strong and ductile property at room temperature. So usually metals are strong and also have this ductility, which means that you can stretch the material to a certain extent at room temperature. Metals also have a good strength at high temperature, and it is shiny when polished. So usually most of the metals are gray in color and it has this shiny property as well. In terms of classification, so we have two big classifications for metallic materials. One we call as ferrous metals and alloys like steel or cast irons. One as non-ferrous metals and alloys, which are aluminum, copper, zinc, titanium, nickel, etc. So the easy way to differentiate this between ferrous and non-ferrous metals is ferrous metals can stick to magnets. So if you have a magnet, then you put a magnet on a metal. If it sticks, then it's probably a ferrous metal, because if there is some form of iron inside, then it will make the magnet stick. But non-ferrous metals will not make the magnet stick. So aluminum, for instance, if you put a magnet on aluminum material, aluminum tin cans, for instance, you won't make the magnet stick. Okay, so that's the big differentiation between ferrous and non-ferrous metals. So whether you have iron inside or not will determine whether it's ferrous or non-ferrous. There are some examples here. So for metals, it's easy for us to know that iron is a metal, copper, aluminum, nickel, titanium. And it's good to know that nowadays we don't usually use the raw iron or raw copper. We have a mixture of elements. So maybe you make the iron melt, you make the copper melt, and maybe you put a little bit of iron and then more of the copper, for instance. Then when it is a mixture, we call this alloys. So it's not only just, for instance, pure aluminum or pure magnesium, but it's a mixture of maybe aluminum and magnesium a little bit, and with that it's called alloys. So we'll cover this more in more detail afterwards. For non-metallics, I think you also know this as well. It's carbon, nitrogen, oxygen, and these are gas, right? So it's not metallic materials. Not metallic materials, metallic elements in the periodic table. Okay, some applications of metallic metals. I think you are also aware of this. It's everywhere when around us. So For instance, the aircraft turbine engine parts. So all of these parts, even though there are some other materials involved, but the majority is regarding metallic metals. There's also mechanical parts in your printers, in your mobile device, in automotive engines. We have gears, we have lots of other things, valve, things like that. So these are all metallic materials. We also have like in bridge structures, so the main component is usually metals. The reason being is strong. It has a strong property, which means that cars can go through it without any issues of it breaking down. And even though there are still some other materials like concrete, rubber, probably, and some other components, but the main structure is still metal. Okay, moving on to polymeric materials. By definition, polymeric materials are materials made of long repeating chains of molecules. So we have in the atomic scale, when we look into it, we see the molecules having a long repeating chains of the same thing. So in terms of properties, we have the structure being most of it are crystalline, and some are mixed. Some are mixed in the sense we have crystalline and also non-crystalline. But when it's not non-crystalline, we have the structure of the atoms a little bit not is not aligned properly. So some in some case we call it amorphous structure. And we will discuss this in detail more later. Just a rough view of what polymetric materials are. It varies in strength and ductility, and it has a poor conductivity of electricity. So when you use polymetric materials, you cannot conduct electricity, but it has good insulating properties. So insulator means that it can retain the heat. So if you have heat involved, it will not make the heat go away easily. Okay, and it also has a lower density, which means it's more lighter compared to metals and have low softening temperature. In terms of the classification, we have two big classification. One, we call it as natural polymeric materials, which are wool, silk, hemp. Hemp is a plant, and natural rubber. So the rubber that we get from the rubber state in its natural form, we call this natural rubber. And we also have synthetic, or in another word, it's called it is man-made. So we have polyethylene, polypropylene, synthetic rubber. So again, when you put something inside the natural rubber to make the property better, we call this synthetic rubber. So like tires, all of this have we call this synthetic rubbers. Nylon and silicone. So there's general properties of polymeric materials, but and it has a wide use everywhere. Okay, so in terms of applications, you can see, for instance, tires, 3D printing also. So 3D printing, we're using polymers. We use plastics to melt the plastic and then make the component layer by layer, and then we get this beautiful like owl or other shapes. This we use polymeric material. So this is a typo there. And then we also have fabric like nylon. So nylon is made of polymeric materials as well, and it is also widely used around the world. Now we go to the ceramic materials. By definition, it consists of metallic components and non-metallic components chemically bonded. So in the atomic structure sense, you will see that both of these are combined together, metallic and non-metallic elements. Usually combination of materials of semiconductor with oxygen, nitrogen or carbon. So this is just a definition. But the important one is consists of metallic components and non-metallic elements as well. Okay, what is the properties that make ceramic materials unique? It's the structure. So we have crystalline, sometimes non-crystalline, and sometimes a mixture of both. So this is kind of unique because for metals, it's only usually just crystalline. For polymeric, we have a mixture of both, but in this case, like you can have crystalline, non-crystalline, and or mixture of both. In terms of the property, it has very high hardness and also very high temperature strength. So even if you go at a very high temperature, it can still retain the strength. It is brittle, lightweight, but high strength. So it has a very high strength, but at the same time, high strength means that it's brittle. It can break easily, and when you see the application, you will understand why this is the case. It has good heat and wear resistance, and it can reduce friction. So if you have heat involved, then the ceramic can resist the heat. So it is a good insulator as well. And at the same time, it has wear resistance. So when you have wear resistance, it means that it doesn't the shape of the material doesn't change easily. Again, it has an insulative property, as in the sense that it retains the heat. Okay, some examples of it is the application. Again, it's this materials. Sorry about that. We have a bathroom sink. So this is made of ceramic. Okay, so you understand that bathroom sinks are very high, has a very high strength. But at the same time, if you look at this bathroom sinks, sometimes they can break. If you make it fall, then it will break easily. So even though it has a good strength, it has brittle property. Other than that, we have various components as shown here. Even you can make a kitchen knife made out of ceramic materials as well, and also in other parts, bricks like this. We have is also made out of materials like ceramic. Other components involved in this in general in materials is composite materials. So I think we discussed this before regarding composite materials. So by definition, composite materials are materials which is made up of two or more distinct materials. So we have what we call as a matrix and reinforcement. So what is both of this? The matrix is the main component of the material, and reinforcement is what we add on to the matrix to make the property much better. So this is kind of a hybrid of two materials to make the component much better. This is what we call as engineering materials, because before this people use it separately, and then people think about how to make the materials better, and they come up with a better solution by combining two materials. So good example here is concrete. So concrete is made of sand and cement, and when you mix these two together, you get concrete, right? So if cement alone or sand alone, you can get a separate property, but when you combine it together, you get concrete, which are much better than sand and cement in terms of strength and other properties. So in terms of the property in general, for composite material, we have produced materials which are different to the properties of the original materials. So most of the time, it's basically trying to improve the original property of the materials. This is important because in some cases we need more strength, for instance, like as an example of the concrete. So this is also the case for other materials or other components as well. And as I mentioned earlier, it consists of a bulk material, so we call this as the matrix, and then we have the reinforcement. So in the case of carbon fiber, for instance, we have the resin, and then we put in carbon fiber inside as the reinforcement to make the material much stronger, much stronger, right? So most of the time it will increase the strength and the stiffness of the material. Okay, in terms of the types of composite materials, there are three. So one is polymer metric composite, we call this PMCs. We have metal matrix composite, MMCs, and ceramic metric composites, CMCs. So this, I won't go into detail about all these three, but just it's good to know that there are several components in composite materials. Maybe in the later stage we will discuss about this a little bit more. Okay, so these are some of the applications of composite metals. So we'll see that we have here, for instance, a luxury boat, and most of these boats are made of glass fiber hull, and the superstructure is also made of composite materials. Sorry, this is materials. Why we make it into composite materials is because one, it has the lightweightness of the property, so it becomes lightweight. At the same time, because it is a composite material, we make it stronger, right? So there is the strength, and we also have a lightweight. We really would like to find materials that are like this, light at the same time still strong. Okay, and we also have, for instance, as we mentioned before, carbon fiber resin bikes, and we can see that apart from the other parts, for instance, the main component, which is the frame, is made out of carbon fiber. Again, why we use this is because we want it to be light, so the racer can go very fast. At the same time, we want the material to be strong, so even though the racer falls, or the biker falls, the bike itself won't break easily, right? So this is two main components that is highly sought after, the lightweightness and also the strength of the material. Okay, and then we also have in helicopter rotor hubs and blades. So some of these components are also composite material. So we combine again both lightweight and also strength in order to make the helicopter more easier to lift off, and at the same time it still has the strength, it won't break easily. Again, when you want to have a fast vehicle, for instance in a F1 sports car, then you will want to use carbon fiber again. Carbon fiber is really good in terms of the strength and also the lightweightness, but the main drawback usually is regarding the cost. So when you want to use carbon fiber, it is costly. But when it comes to using it in a race, or competing in Olympics, things like this, maybe money is not a big issue, and then we can get the best performance in this competition. Then we also have the last component, which is the semiconductor materials. This is might be the least that we talk in this course. By definition, it's a solid material that have a conductivity between insulator and most metals. So as we mentioned before, insulator is, for instance, the ceramic materials. So it will not conduct electricity, it will not conduct heat. But in terms of metals, metals can conduct heat and conduct electricity very well. Semiconductor is between the insulator and metals. So the main application for semiconductor materials is basically electronic materials. So in your computer, in your smartphones, and in most of the electronic devices, we have semiconductor materials inside. Okay, the properties is a little bit difficult to understand, but it's okay for now. Semiconductor materials are capable to alter electrical conductivities in their surface chemistries in very localized areas. So it has a unique property which is very important in electrical components, but we won't go into detail about that. In terms of classification, there is two types. One they call as N type, which has an excess of electrons, and the other we have P type, which has a shortage of electrons. So this will play part in how the semiconductor material behave when it comes to the electrical components in our electrical device. Okay, so I won't go into detail, but you can see here some of the components we have in our electronic devices, and these materials are very important to make the electronic device function very well. So when you understand, we have metals, we have ceramic, we have polymeric materials, we have semiconductor materials, and whatnot. And now the question arises is, how do we select a material properly, right? So we don't when we are tasked with a situation, do we just pick any material, or we have a proper selection process? So these are the three steps that you need to consider, even for your upcoming projects. You might want to also follow this selection process. So there's just three steps. First of all, you have to think about what the application is. So what application do I want to for this material to be used, right? So when we know that, for instance, or this is going to support other components, for instance, then we try to determine the required properties. So when you want to support things, then maybe you want it to be strong, right? So in terms of the mechanical strength, we have to make it strong. You try to consider, do we need the electrical properties to be good or not, right? So if you don't, you need to consider that, and maybe you can take that off. But you can also consider other properties as well. So once you understand that and you identify what property is needed for this application, then we go to step 2. We try to identify the candidate materials. Now we say, oh, okay, for this situation, maybe metal is good, or in this situation, maybe semiconductor is good, or in this situation, maybe polymeric materials is good. And once you know that, based on the structure, the composition, and the other properties as well, we go to the step 3. So we've selected the material, which one is better, and now we have to identify the processing aspect. So in processing, again, we might go into more detail afterwards, but there are several types of processing. For instance, casting, sintering, joining, vapor, deposition, and things like this. This will change the structure and overall shape of the material, and we have to consider that when we want to select a material. So again, what type of application we want to use, and then what are the properties we need to have to make sure the application can be used properly. And then from there we can select the material, and from that material we have to also consider how to make it, right? How can we make it for us to use in this application? So these are the 3 steps of material selection process. What we should understand from here is we want to use these steps to select the right material. So in summary, for the introduction to engineering, material science and engineering, we need to use the right material for the right job. There's no one wonder material. We have to think of what the material application is for, and we also have to understand the relationship between the property, structure, performance, and processing. We will go that in more detail after this. This is just a general introduction first. And we also have to recognize the new design opportunities offered by material selection. So if we can select properly, then maybe we can think about new designs opportunities. Okay, so I'll leave this to you for you to read some of the tutorial questions. We can discuss this in more detail in our next class. With that, we finish our first video for this course. Thank you very much.